So the next category of compounds that we're going to learn to name and write formulas for are the molecular compounds. These need a different system of naming, a different system of nomenclature, because there are no charges involved, and so we can't use those charges to find out, well, how many nitrogens and how many oxygens would go together. And in addition to that, you can have the same two elements, and they can combine in lots of different ways. There are actually 6 different molecular compounds that form between nitrogen and oxygen. And so each of these needs to have a unique name and a name that describes the formula. So, important to remember, molecular compounds in Chem 1A are composed of 2 nonmetals. We're going to use the same numerical prefixes that we just looked at for the hydrates, and we're going to use these prefixes to tell how many atoms of each element are in the compound. You may wonder, well, why do they write the nitrogen first and the oxygen second? Why don't they do it the other way? Why is it H2O and not OH2? We put the more metal-like element first, and it's usually the one to the left. You don't really need to know that, but I know some of you are curious about that. So this is the pattern for naming. There'll be a prefix before the name of the first element. This is not a metal, but it kind of acts like the guy in the relationship. So just like the metal, the element name and the ion, well, it's not an ion name, but the name in the formula are the same. It's not going to change any endings. The second element acts like the woman, changes the ending of her name. They are having way too much fun in there. Like, we should start singing or something and make them jealous. Anyway, a prefix in front of that. Now, in chemical formulas like this one, NO2, we didn't write the 1, did we? Because it's not really necessary. A lot of times, if there's only one atom of the first element, then that mono prefix is always also left off. I will not try to trick you with that, but it is a thing that sometimes people disagree about. So if we look at this compound NO2, we see there are exactly 2 nonmetals, nitrogen and oxygen. We're going to name the first one first, and that's nitrogen. There's only one, so we might think it should be mononitrogen, but we often leave that out. The second one is oxygen, and it's going to act like an anion in that it changes the ending of its name, so oxide, and the prefix di for the 2 oxygens. Nitrogen dioxide. This is another thing that you should remember. In Chem 1A, we have 2 compounds that are always going to use their common names. So we just need to remember them. H2O is water, and NH3 is ammonia. Now, these have systematic names, dihydrogen monoxide, nitrogen trihydride, but we never call them that. So I will try to trick you with these guys. Ask you about ammonia, and you're like, wait, what the heck? You're supposed to know the formula for ammonia.
I had a teacher who made a joke about the systematic name for water. He was like, dihydrogen monoxide kills more people than anything else. It's like,
Yeah. Because people drown.
Yeah.
Yeah. Well, and you can really mess with people. It's like you go home and like, my teacher made us drink dihydrogen monoxide in class today. That was so scary. Yeah, I sent you out to the water fountain because you were thirsty, right? You give it a chemical name, people.
100% of all people who drink dihydrogen monoxide die.
Yeah. We're all dying, right? We're all going to die eventually. Yeah, so perspective is kind of interesting sometimes. Okay, let's name the compound N2O5. Well, the first element is nitrogen. And there's 2, right? So, dinitrogen. And the second element Oxygen becomes oxide, and prefix for 5, penta. So pentaoxide. Dinitrogen pentaoxide. Let's write the formula for phosphorus tribromide. We need the element symbol for phosphorus, which is P. How many of them are there? 1. It doesn't say mono, but it also doesn't say di, tri, or anything else, so we can assume it's 1. And then bromide is the element bromine, right? And how many are there? 3. So this system tends to be the easiest for students. But the problem with that is that then they want to use it everywhere. And you can't use it everywhere. So it just needs to stay with 2 nonmetals. Yeah?
Is there a reason why all of them were lowercase letters when you named them? Because I noticed in every example previous it was all lowercase letters.
That's a great question. Why is this all lowercase letters? Because,
Top and two.
yeah, and up here. So the name of a compound is not a proper noun, right? So, when you say, I have a dog, well, dog is the name of the animal, but that's not a proper noun. We don't capitalize it. But if I talk about an individual person, we capitalize the first and last names. Or a city, you capitalize the name. And this is something that might give you a little trouble on the worksheet 3 quiz where you're checking your answers. I remind you right in the quiz, do not capitalize compound names. But some students just want to capitalize everything. And I didn't want to type in all the combinations with capitals and lowercase. So if you use a capital letter, it's going to tell you it's wrong. But when I look at your quiz, if I see that you wrote the right name and you just capitalized it, I'll give you credit for it. Okay, but that's why. Good question. Another type of molecular compounds are acids. So the rules we just looked at apply to binary molecular compounds. Did you have a question?
Yeah, I was going to ask on the naming molecular compounds, that's only for non-metal?
It's when you have 2 nonmetals. Yeah. And so what we're going to see now is that there are compounds that might have 3 nonmetals. The only kinds of those that we're going to come across are going to be acids. There are also some acids that have exactly 2 nonmetals. And those could be named either way. So acids are molecular compounds. When they are dissolved in water, they're going to form hydrogen ions. So something like HCl, so we look at that and it's like, well, that's 2 nonmetals. That's a molecular compound. Yes, it is. It's a molecular compound. When you put it in water, though, it forms ions. So it's kind of weird that way. The ions that it formed can be predicted using the same ways that we predicted ions for ionic compounds. The acids we'll encounter in Chem 1A always have hydrogen in them, and hydrogen is always the first letter in the formula. So when you see a formula and it starts with H, that's an acid. It starts with a metal, it's an ionic compound. If it's exactly 2 nonmetals, you can use the prefixes to your heart's content. Typically, we'll write the symbol AQ to mean that something is dissolved in water. So H plus AQ means these hydrogen ions are dissolved in water, and these chloride ions are dissolved in water. If a compound containing hydrogen does not dissolve in water, then it's not considered an acid. So that's true, but we don't actually need to know that because I'm just not going to give you anything like that. Okay? One of the nice things about a classroom setting is you can leave out some of the more problematic exceptions, some of the trickier stuff. We just won't talk about it, so we don't have to think about it. So acids have some common characteristics. They taste sour. So any foods that you eat, like lemon juice or lemon anything, or Sour Patch Kids, any food that is sour has acid in it. Our bodies actually can handle acids pretty well. It's bases they have a lot of trouble with. Acids can dissolve many metals, but not all of them. And here's an illustration of zinc metal dissolving in hydrochloric acid. Their formulas in Chem 1A always start with H. So HCl, H2SO4. Starts with H, it's an acid. We can talk about two different kinds of acid, and there's two different ways of naming them. The book talks about binary acids and oxyacids. I prefer to think of them as oxyacids and the not oxyacids. So oxyacids have oxygen in them, the others do not. The book calls these binary acids, and the reason I take issue with that is that there are some acids that are named as binary acids even though they have more than two elements. It just bugs me. But they don't have oxygen, so they fall into this doesn't have oxygen category. So you've got hydrogen and nonmetal but no oxygen. We're going to use the prefix hydro to represent the hydrogen. And then we're going to look at the nonmetal and change its ending to ic, and then add the word acid at the end. So hydro, the element name with the ending changed to ic, acid. So let's look at this one. So HF, is that an oxyacid? Does it have oxygen? No, it doesn't. So this is hydro something ic acid. Yeah, so hydro, and fluorine is the other element. So we'll take the fluor part and change the ending to ic and add the word acid. All of the acids in Chem 1A have acid in their name. They all start with H. They all have acid in their name. And we can go the other way and take the name and write the formula. So hydrosulfuric. This hydro part is the hydrogen, and sulfuric comes from the element name sulfur, right? So that's going to be S. How do we decide how many of them to put together? Well, when you dissolve hydrosulfuric acid in water, it makes ions. The same kind of ions that we see in ionic compounds. And so we know that a sulfur ion is going to have a 2- charge, and a hydrogen ion is going to have a +1 charge. Hydrogen is over in group 1A, and even though it's not a metal, it does do +1 charge. So we look at the charges on the ions that are formed, and then we can see that we need 2 hydrogens. So this is going to be H2S, and ideally we would put AQ behind it. In some situations, if it's not aqueous, it would be named as a binary molecular compound, so dihydrogen sulfide. I'm not going to make you remember that distinction, but if you see it that way, that's why. The nice thing about figuring out the formulas for these is the cation we're dealing with is always a +1 charge, H+. And so whatever this charge is, this is 2-, I need 2 hydrogens. If it's 3-, I need 3 hydrogens. And so it's a little easier that way. Any questions? Okay, so for the oxyacids, acids containing oxygen, these have oxyanions in them. I feel like I missed. No, I didn't. So we're going to look at the formula, cover up the H part, and the rest of it is an oxyanion. And we should be able to say that name from memory or figure it out, right? So we're going to find the name of the oxyanion. If the ending of the name is 8, we change it to ic. If the ending ends in "ite," we change "ite" to "us," and we put the word acid at the end. There's no hydro at the beginning. So how do we keep "ate" and "ite" and "ick" and "us" straight? Well, there's two silly sentences. The white mouse ate icky cheese. So there's "ite," "us," "ate," and "ick." These two go together, and those two go together. I've heard other instructors use that one. I have one from my history as a student. I have no idea where it came from, but it amuses me. Whoops. Rick ate him before he could bite us. Isn't this weird? So there we've got our "us" and our "ite," our "ick" and our "ate." You want to make up your own silly sentence? Go for it. Okay, so here we have a compound. It starts with H. It's an acid. So let's cover up the H and look at what's left. Well, that's an oxyanion. So we need to know the name of that oxyanion. So NO2 minus, what's the name? So there's two reasonable guesses, nitrate and nitrite. Happens to be nitrite. Nitrate has 3 oxygens. So that's the nitrate ion. Well, I guess I should put that over here. And I'm going to take that 8 off and change it to ick or us? Ick. So this is nitric acid. Okay. If we had hydronitric acid, that would be something else. So hydronitric acid the prefix hydro tells me that this does not have oxygen in it. It's just hydrogen and, in this case, nitrogen. And hydrogen always has a positive 1 charge. Nitric comes from nitrogen, which is a negative 3 charge. And so the formula for that would be H3N, aqueous. So nitric acid and hydronitric acid are different acids. Let's write the formula for perchloric acid. Does this start with hydro? No. So this is not one of the binary acids. This has an oxyanion in it. So perchloric comes from perchlorate ion, right? Ick and ate go together, switch them. What's the formula for the perchlorate ion? ClO4 minus. Chlorate is the one you should memorize, a ClO3 minus, and this has an extra oxygen, it's hyper, so perchlorate has 4. And it's going to have a hydrogen ion, and since the charge is -1, the formula is HClO4 aqueous. Yes?
Shouldn't HNO2 be nitrous acid?
Yes. Yes, it absolutely should. Yeah, it should. How about that? Just change it. No, NO2 nitrite. Those are easy to mess up. So nitrite, and so this is nitrous. I thought that wasn't going very well. But over here with the hydronitric acid, nitric acid would be from nitrate, which is HNO3. So that's nitric acid. Thank you very much for pointing that out.
Thank you.
Any other questions? We already kind of did this, but writing formulas for acid. So the name has acid in it, the formula starts with H. You write the formula as if it were ionic, even though it's molecular. When we have that hydro prefix, we've got what they call a binary acid. If there's no prefix, we've got an oxyacid. For those oxyacids, you look at the acid name, and if it's ic, like nitric acid, that comes from the polyatomic ion ending in 8. And if it's us, like nitrous acid, it comes from nitrite.
So we use this ick, it's a poly all the time?
If it has, well, we need to associate ic and 8. So if you have the acid name, it's going to have ic. If you're writing the formula, then you need to translate that to 8. If you have the formula and you're trying to write the acid name, you look at the name of the anion, ends in 8, and you put ic in the acid name. And then ite and us go back and forth. Okay, let's do some extra examples. Hydrocyanic acid. Is this an oxyacid? No, because oxyacids don't start with hydro. So this is hydrogen ion and something else. Well, cyanic. It's not an element. It's a polyatomic ion cyanide. And it is on that list. It's CN with a -1 charge. This is the main example that I don't like calling it binary acid, because this falls in that category, but hello, it's got 3 different elements. So this is HCN, aqueous. Phosphoric acid. Oxyacid or other kind? Oxyacid, because it doesn't have hydro. So let's see if I can do it right this time. Phosphoric comes from phosphate or fight? 8. White mouse ate icky cheese, or Rick ate him. So this is from the phosphate ion. So I need to write the formula for the phosphate ion. So it's going to be phosphorus and oxygen, and then, what do you think? How many oxygens? It's got 4, and the charge? It's -3. Because that's what it is. And you have to remember it. Okay? So as you're doing worksheet 3 and the problems for homework 3, and you have to write these things, try to do it from memory and then check, because you'll learn it faster that way than if you just go look it up every time. Okay, so how many hydrogen ions does this need? 3. The charge is 3 minus. The hydrogen ions are always +1. So I need 3 of those. This is H3PO4 aqueous. Hypochlorous acid. Oxyacid or other kind?
Wait, no.
I put this one in here because it's tricky. Hypo and hydro, like really similar, right? HY, and if you take the P and flip it up and reverse it, it becomes a D, right? But this is hypo. So hypochlorite